Hi everyone, this is my second video on sequence and series. So now I'm going to cover the convergence by graph, use of subsequence for convergence, and two previous year question and answer. From the last video's comment, I realized that I should discuss about 2 points, and so I'm going to discuss the convergence by graph again. Since n belongs to natural number, so our graph can't be a continuous graph. So now you can see that I have created two graphs, the figure 1 and figure 2. In figure 1 the graph is discrete, and figure 2 the graph is continuous. For figure 1 you can see my capital N is equals to 9. So this is a very small number. So drawing the discrete graph, it will be suitable for the convergence. But for the figure 2, I am assuming that the capital N is a very big number. So before that n, I have many natural numbers. So I am assuming that the points are very close, so the graph is looking like continuous, though the graph must be a discontinuous graph. So the sequence n will be convergent when the graph is being parallel to the x-axis after a certain time, that is n greater than equals to capital N. So we can see that after n greater than equals to capital N, an is being equal with the L, or we can say that an is tends to L. So an minus L is being very small. So we can say that mod of an minus L less than epsilon for all n greater than equals to capital N, where epsilon is a very small positive number. So we can say that an is convergent sequence. What is subsequence? Subsequence is also a sequence whose elements are from a sequence. So suppose from a sequence, if we drop a few elements, then the remaining sequence will be a subsequence. For example, here you can see that minus 1, 1, minus 1, 1, minus 1, this is a sequence, and if we create another sequence like 1, 1, 1 or minus 1, minus 1, then these two sequences will be two subsequence of minus 1, 1, minus 1, 1, minus 1, 1. Here we have to remember that a sequence contains infinite numbers. So we can't take only few elements from a sequence and call them subsequence. So it must satisfy the conditions of sequence also. This is a very important theorem. Every subsequence of a convergent sequence converges to the same limit as the original sequence. So if a sequence an converges to L, then every subsequence of an is going to converge to the same limit point L. Now we can see that the sequence 1, 1, 1, 1 and minus 1, minus 1, minus 1 are converging to 1 and minus 1, which are two different numbers. So we can say the sequence minus 1, 1, minus 1, 1, minus 1 must be a divergent sequence. This question is from IIT JAM MS 2015. Here they are using the concept of subsequence. So you can see the question is, if a sequence xn is monotone and bounded, then the options are: option A, there exists a subsequence of xn that diverges; option B, there may exist a subsequence of xn that is not monotone; option C, all subsequence of xn converges to the same limit; option D, there exist at least two subsequence of xn which converges to distinct limits. So here since xn monotone and bounded, that implies xn is convergent. So by our previous theorem, all the subsequence of xn converges to the same limit as xn. So easily you can say the third option is the C option is the correct answer. Let us explore the other options. The option A, there exists a subsequence of xn that diverges. So, if xn is convergence, then all the subsequence is going to be convergent. So, option A is wrong. Option B, there may exist a subsequence of xn that is not monotone. So, since every subsequence is going to be convergent, so it must be bounded and monotone. So the option B also wrong. Option D, there exist at least two subsequence of xn which converges to distinct limits. So it is not possible since all the subsequence is going to be convergent to the same limit points. So option D also wrong. I have a interesting story to say about this question. So you can see it's looking like a complicated nth term. This question is from 2017. So when I attempt this question, actually that time I just stuck and I was unable to think about it. So what I did, I used the virtual calculator. So in the place of n, I have put a very large numbers like 1000, 2000, 3000, some even numbers and some odd numbers, and I got the result near 1. So I was very sure that the D option is the right option, and I got the marks for this question. You can try also. Now let's discuss about the solution. So this is a very easy question, like take the log on both sides. So you can see that we get a log un equals to minus 1 to the power n by n log of 4 minus 1 by n. Then take the limit tends to infinity. We know that limit of ab equals to limit of a into limit of b. So by that we can divide this as limit of minus 1 to the power n by n and limit of log of 4 minus 1 by n. So here log is a continuous function, so we can interchange log and limit. So from limit tends to infinity minus 1 to the power n by n, it's going to be 0, and log of limit instant to infinity 4 minus 1 by n, it is actually 4. So we are getting log 4 from there. So 0 into log 4 equals to 0. So our limit instant to infinity log of un is equals to 0. So what is the limit un? You can see that L equals to limit instance to infinity un. So we can write un as e to the power log un, since e to the power log un equals to un. So from here we can write e to the power limit instance to infinity log un, since limit and e can be interchanged, since exponential function is a continuous function. So we have L equals to e to the power 0, that is 1, and this is not equals to 0. So first of all we get our value L equals to 1, and we know that if un is convergent, then limit instance to infinity un must be 0. But since here limit of un equals to 1 not equals to 0, so un is a divergent series. Let me know your comments to improve the videos. Thank you. All the best.